Hi, today we're going to take a little bit different look at factoring, and we're going to do factoring solving with exponential functions. All right, so it'll be something like if you look at the first problem that we have, 3x to the 7/3 plus x to the 4/3 minus 2x to the 1/3. So if you're going to do a problem like this, the first thing that you need to do is you need to factor out the variable with the lowest exponent. In this case, that is x to the 1/3. So I'm going to factor that out. So I'm going to take out an x to the 1/3 power, which means that I would be subtracting it out. So I'm going to take 7/3 minus 1/3. So that gives me 3x to the 6/3 or squared, plus subtract out 1/3. So 4 minus 1/3 gives me 3/3 or just x minus, and when I factor out the 1/3, that factor is gone. Now I have something that I'm used to seeing, and I can just continue to factor that problem the way that you would normally factor it. So however it is that you do that, if you're looking at it and you said what multiplies to 6 adds to 2, however it is that you do your factoring, you can now factor that. So I know 2 and 1 plus and minus. And oops, I left out the x. Sorry about that. And then I have the answer that I need with that. So x to the 1/3 times 3x minus 2 times x plus 1. So that would be the total factored formula. But just remembering you're factoring out whatever the variable is on that is going to be the lowest one. All right, so if I were to have something like this one, my lowest factor is going to be x to the -5th. So I want to take that part out. So I also want to deal with, I really don't want a 1/4 in the front. So I'm going to factor out a 1/4 x to the -5th power. So 1/4 divided by 1/4 is going to give me 1. If I subtract out this problem, that gives me -3 minus -5, which is going to be a plus. So that will make it x squared. If I take -3 divided by 1/4, that's like multiplying by 4. So that's going to give me -3. Sorry, that would be wrong. So I'm going to multiply by 4 on that one. And when I multiply by 4, that gives me 12. So minus 12x, and -4 minus -5 is just to the first power. Minus 11 divided by 1/4 gives me minus 11. And then I want to see, is it possible for me to factor that anymore? And this time it's not, the way I have the problem written. But if I were to change this to plus, and then that becomes plus 11, then I can redo this problem. So that gives me x minus 11 times x minus 1. And I don't want to leave necessarily a problem that looks like this. So I can keep this. And then 1/4 puts a 4 in the denominator, x, and I know that if I move the -5 to the bottom, it becomes positive. So that would be more of an answer that I would like to see if I'm factoring with that. So again, always take out the lowest denominator. Now this problem becomes a little bit different. While this is still going to be the lowest one, you need to remember or you need to think about this being, well, this is not really 2, it's really 2x to the 0 minus 3x to the negative 1 plus x to the negative 2. Working with that, and I know still that that's the lowest one, so factoring that out, negative 2 would be 2, 0 minus negative 2 would be squared, minus 3, 1 minus negative 2 is to the first, and then negative 2 becomes a plus 1. Now I want to look, can I factor this piece? So that gives me x to the negative 2 times 2x, and again, however it is that you do your factoring with that. So I could say what multiplies to 2 as a 1, but this is a 1, 1, and minus, minus. So I have the problem factored. And then if I don't want to have a negative exponent here, then I can rewrite this so it's a little bit nicer to 2x minus 1 times x minus 1 divided by x squared. And then that is going to be a kind of answer that you're looking for in doing that problem. Okay, the next one. This one has a binomial that I'm going to be taking out. So I look at that part as well. When I begin looking, I can see there's a 3 and a 12. So I can factor out a 3. Both of the binomials are the same. So I can factor out an x minus 1. Negative 4 is the smallest. So I take out to the negative 4th power. 3 takes out 3, and it leaves me x. X minus 3 minus 4 is 1 times x minus 1 plus 12 divided by 3 is 4. And then minus 4 takes that piece out. And then if you simplify, 3x minus 1 to the negative 4th, and then x squared minus x plus 4. Is there anything that multiplies to 4 and adds to negative 1? So that's no, so I can't factor anymore. So if I was getting rid of my negative exponents, I would have 3 times x squared minus x minus 4 over x minus 1 to the 4th power. And then that would be the answer that you're looking for. Sometimes it's okay to leave it in this, but just depending on what you're looking at can tell what you need to do with that. All right, now this problem, I'm going to have to think a little bit outside the box. And all of the other problems, we had a common base. There's a 25, there's a 5. They don't have a common base. But is it possible to make them have a common base? Well, yes, I can rewrite 25 to the x as 5 squared to the x, or 5 to the 2x power. So I'm going to redo this problem and rewrite it as 5 to the 2x plus 5 to the x plus 1 plus 4. Now, I want to think about, what does it mean if I have 5 to the x plus 1 power? Well, that would be remembering you add exponents, so you keep the base and you add the exponents. So that would be the same as saying 5 to the x times 5 to the first, which puts this as a coefficient. So I can rewrite this now and make a little simpler terms from 5 to the 2x plus 5 times 5 to the x plus 4. All right, once I have the problem written like this, I want to take a look at my problem and see, is this exponent half of this one? And if that answer is yes, then I can solve through the problem, or I can possibly factor it out. So one way to do that would be to play a game, let u. And I want to let u equal whatever is in this position. So in this case, it's going to be 5 to the x. So if I have 5 to the 2x, that becomes u squared plus 5u plus 4. Now, once I get it in this format, that is something that I'm used to seeing. So I can now just factor it like I would normally factor something. What multiplies the 4, but adds the 5. So u plus 1 times u plus 4. But this problem did not start out as a u. It started out as a 5x. So now I can go back in and I can substitute in what u was. So 5 to the x plus 1 times, and then u again is 5 to the x. So I'm now just simplifying that part out of it, plus 4, and then that is going to be my final answer. All right, part of this was to solve. So if I want to solve this problem, I'm going to just do what I was doing in the first few problems that we had. Okay, we're going to factor out what is the lowest exponent, which is this one. So that would give me x squared plus 1 to the negative 1/3 times 2/3 minus negative 1/3 is 3 over 3, or 1. So that leaves me x squared plus 1 minus, when I factor that out, that's 1, equals 0. So that gives me x squared plus 1 to the negative 1/3 times x squared is equal to 0. Getting rid of that, so x squared over x squared plus 1 equals 0. Okay, well, I know this cannot equal 0. So I don't need to worry about solving that part out. So I just look at this part, x squared equals 0, so x is equal to 0. So my answer to this would be x is equal to 0. You want to be really careful with that. Let's say my denominator had been, instead of x squared plus 1, if it had been x squared over x squared minus 1, remember x cannot equal 1 or negative 1, because that's going to be in the denominator. So that's just kind of like a think about it, and remember your domain restrictions. Okay, this one, again, think about what I said last time. If this is half of that, it is possible to try to factor. So that is half of it. So we're going to say, let u equal x to the 1/3 power. So substituting it in would give me u squared plus 3u minus 10 is equal to 0. Factor that, u plus 5 times u minus 2 is equal to 0. And then I can substitute in x to the 1/3 plus 5 times x to the 1/3 minus 2 is equal to 0. And now this becomes like any other problem that you would do. Set each part equals 0. X to the 1/3 plus 5 equals 0. X to the 1/3 minus 2 equals 0. Move over the 5. Get rid of 1/3 by taking it to the third power. So x is equal to negative 125. Move over the 2. X to the 1/3 equals 2. Again, take it to the third power. X is equal to 8. And now I would have solved it. But let u is always a nice, helpful thing. If you don't need let u, you could just begin factoring it yourself. But a let u is always kind of a nice fallback to go on. All right. Looking at this problem, I actually didn't mean to start it this way. So I'm going to change the start value of it so you can kind of like see what you would probably see in working this problem. If I said this was 16 to the x power. So the first part of what you're doing on here would be this and this do not have a common base. So remembering 16 to the x is the same as 4 squared to the x power, or 4 to the 2x power. So I can rewrite this as 4 to the 2x minus 10 times 4 to the x plus 16 is equal to 0. Looking, and I can see this is half of that. So let u equal 4 to the x. So doing that changes this to u squared minus 10u plus 16 is equal to 0. Factor u minus 8 times u minus 2. Substitute back in what you were supposed to do with that. So 4 to the x minus 8, 4 to the x minus 2 equals 0. Split it. So 4 to the x minus 8 equals 0. And 4 to the x minus 2 equals 0. So 4 to the x is equal to 8. Get a common base, and the common base would be 2. So 2 to the 2x equals 2 to the third. If the bases are the same, the exponents are the same. So 2x equals 3, x equals 3 over 2. Same here. 4 to the x equals 2. 2 to the 2x equals 2 to the first. 2x minus 1, equals 1. X equals 1/2. And then there is your next problem. All right. So hopefully that helps out a little bit as you were kind of working through these problems. I know it's a little bit different than what you're used to seeing. So please let me know if you guys have any questions.